Okay, let's practice converting polar equations to and from rectangular equations. Don't forget, sort of, here's the motivating picture. If you have something in rectangular coordinates, that tells you x, how far over, y, how far up. If you have something in rectangular polar equations, that tells you r, how far out you go from the origin, and theta, how far you rotate counterclockwise from the positive x-axis. And so here are the equations that we get out of that. And so let's sort of think about how we convert. Let's first do a couple of examples going polar to rectangular. Okay, so let's see. You might have something like r equals 3. Well, you know, if you have r, you either need a cosine by it or a r squared, so let's just square both sides. R squared equals 9. Well, what's r squared? R squared is x squared plus y squared equals 9. Well, you can sort of see, so this is the conversion and you'd be done. But you can sort of see in polar coordinates, this is the set of all points, no matter what the angle, that has a radius of 3. So that would be that. And that would be exactly the same as that rectangular plot. That's the circle centered at the origin of radius 3. You know, you could do something else like r equals 2 sine theta. I need something with my sine theta. I need an r, so let's multiply both sides by r. R squared equals 2 r sine theta. Well, r squared is x squared plus y squared equals 2 r sine theta, of course, is y. So there's your equation. You're set. Now if you wanted to graph both of these, this is actually a circle too, and you could take that over to the other side, complete the square and all that good stuff. But this is sort of a quick and dirty description of how you move from polar equations to rectangular. Maybe we ought to do one last example. How about theta equals, I don't know, 45 degrees. This one's pretty easy to draw the picture. It's every radius, so if r were 1, 2, -1, -2, and 45 degrees, well, you can sort of see that what I'd need to convert this is I'd need to take tangent of both sides. So tan theta equals tangent of 45 degrees. Well, tangent of 45 degrees is 1. Tan theta is y over x. So you could leave it like this, or you could write y equals 1x. And that's, of course, the equation for that line. Okay, so now let's go back. We have rectangular to polar. This works amazingly well if you have something like 2x minus 3y equals 7. 2, well, what's x? It's r cosine theta minus 3, what's y? R sine theta equals 7. So that's a good example. If you happen to have something like x squared plus y squared equals 7x plus 2, well, you could make this, of course, r squared. X is r cosine theta, and of course 2 is 2. So there you have it.